Air travel has become an integral part of our everyday lives, connecting the people on our planet. For some years now, competition among airlines has been increasing. Competition in which modern super airliners play an important role. The Airbus A350 is one such super airliner. Germany's largest airline has already ordered a significant number of these new long-haul aircraft. But can the airliner meet the high expectations? The A350's first official flight goes from Munich to Hong Kong. The high-tech jet now has to prove itself under real conditions. A direct flight and a stress test with a duration of 12 hours.
It's the most modern commercial airliner on the market.
The engines from Rolls-Royce have been completely redeveloped and enable the aircraft to carry out extreme flight maneuvers.
We'll be pushing the aircraft to its limits here.
On a test flight, the new A350 is rolled to a bank angle of 67 degrees. There are also improvements for the passengers. More space and larger HD monitors are just some of the features. But the current super airliner from Boeing also has a lot to offer. New, larger windows and a completely new lighting concept for passengers on the 787 Dreamliner. London to New York in only 3 hours, possible only by flying at twice the speed of sound. But that's only the beginning. In the near future, even flying drones will help alleviate the traffic chaos in our cities. And developers are looking even further into the future with their concept plane.
The concept plane is an example of what the future could look like. This future, we will build it together.
The super airliners for the new millennium are ready to hit the skies. The Airbus factory in Hamburg. The city on the River Elbe is the third largest construction location for civil aircraft in the world. Around 12,000 people work here in development, design, and final assembly. Besides other aircraft, 2 super airliners are being produced on the 19-square-kilometer site. The biggest passenger aircraft in the world, the A380, and the new long-haul jet, the A350. There was even a new assembly hall built especially for their manufacture.
Here, the mechanical and electrical systems are installed for 2 fuselage sections. For the forward section, which starts behind the cockpit, and the rear section behind the wings.
At first sight, the individual fuselage sections all look the same, distinguished only by their different production numbers. Everything runs according to a fixed assembly schedule, which begins with delivery of the front fuselage section. The staff here refer to this as the barrel, in which they gradually install the various systems. That is now much faster than in the old assembly hall thanks to the new construction method. For the fuselage and wing structures, more carbon fiber composites are used than in any other commercial airliner. After only 12 days, one fuselage section leaves the Hamburg works and is flown to Toulouse by the Beluga transporter. This production speed, however, is only possible by using the assembly method known as module integration.
That's a very special assembly method here in aircraft construction. The A350 is currently the only program carrying out installation this way in the entire Airbus group.
In these frames, cables are laid, air conditioning ducts mounted, and small control devices installed. The benefit is that there's no more overhead work, as the modules are only installed in the cabin ceiling at a later stage, a great relief for the technicians. However, everything is still installed by hand. The cables are bundled into so-called race bases and then ducted before these race bases are also installed into the modules. Each individual line is then checked once again by technicians before being installed in the barrel. If everything is okay, green labels are attached with the letters GTI printed on them.
GTI stands for Ground Test Instruction, and there's a precise definition for the way we have to check our contact resistances and the rest of the electrical equipment.
Electrical resistance is measured at various points with the help of a measuring device. This resistance measurement is extremely important for safety during flight operations.
If the contact resistance or general resistance is too high, or the currents flowing over them get too high, as in a lightning strike, it would lead to a lot of heat developing here, and that's definitely not something we would want in an aircraft.
Once the module has been assembled, it's carefully transported by crane to the A350 fuselage. The time saved by this new assembly method is enormous. The manufacturer now delivers more aircraft than ever before. A350 production alone now sees 10 aircraft completed every month. This is also due to the passenger cabin being assembled parallel to the fuselage, wings, and tailplane. Now the retaining bolts are removed and the module is slowly edged towards the fuselage. There are currently 3 versions of the aircraft available. Here, the middle version, the A350 XWB-900, is being built for Lufthansa. The module is slid into the fuselage on a rail. Nothing must go wrong now. The slightest error could bring the entire production to a standstill. The technicians are all highly focused because, after all, the safety of future passengers depends on this. Minor deviations in the height of the module are corrected using adjusting screws. Hundreds of cable harnesses are still hanging down from the module ceiling. They will soon all be laid individually by hand. While work goes on in the upper section of the cabin, in the lower section everything is finished.
We're here in the plane's cargo section, where all kinds of systems are installed that passengers don't get to see.
In the rear section, there are the fresh and wastewater tanks.
There are 2 freshwater tanks installed here, a larger and a smaller one. The larger tank holds about 800 liters and the smaller one around 600 liters. We allow about 40 liters per passenger.
Under this floor paneling is where the A350's oxygen supply is installed. The supply lines are well protected in the middle of the fuselage. Here too is all the cabling for the cargo system. This automatically guides the freight containers into the fuselage and ensures the load is correctly positioned.
Here we've installed the cargo loading system. These are the roller conveyors. They consist of different compartments where the luggage or the freight can be loaded onto. And so it arrives at its destination safely without slipping.
After 15 years of development, the A350 will now succeed the Airbus A340 as the new super airliner. The way it's produced is also completely new. New materials demand new manufacturing methods. Special bolts are used to connect the fuselage sections. The A350 also has reinforced high-speed wings. They are made of CFRP, a carbon fiber reinforced plastic, making them suitable for higher speeds. The extremely smooth wing surface the CFRP creates results in less air turbulence, which in turn means reduced air resistance and consequently more lift. This guarantees greater stability and at the same time 4.5 tons less weight. To build these wings, a completely new process is used. Similar to the principle behind a standard 3D printer, the wings are built up layer by layer. Here, a small model of an aircraft wing is produced, but in the plant at Stade near Hamburg, the upper level of a full-sized wing is printed with the help of a giant roll of adhesive tape. On each of its long sides, there are 12 rotating spools which unroll black strips of CFRP. Large aircraft manufacturers are increasingly using this material to save weight, kerosene, and money. CFRP is stronger and easier to work with than aluminum or other metals. It's also much lighter. In the development of the new super airliner, cooperation with the various airlines is extremely important.
It's a continuous process. Based on our experience in daily scheduled operations and close contact with the manufacturers, Airbus, we help to develop new solutions for future aircraft, which can then later be found in our own fleet.
All A350 parts manufactured in Hamburg are flown to Toulouse for final assembly. This is where the super transporter Beluga comes into its own. The Beluga is the aircraft manufacturer's backbone. It can carry up to 47 tons of freight, the equivalent of about 10 fully grown elephants. Rolls-Royce MTOC in Dahlewitz, Brandenburg is the location for assembly of the new A350 jet engine, the Trent XWB. The airliner has 2 of them. Dahlewitz is the 3rd largest of Rolls-Royce's production sites. 2 XWB-type jet engines are built here every week. With a diameter of over 3 meters, they are among the largest and most modern jet engines in the world. Here, too, most of the work is carried out by hand. Around 70 highly qualified engineers and technicians work here, putting together thousands of individual pieces like a huge 3D puzzle. After final assembly, the engine is tested thoroughly. Up to 40 different tests can be carried out in this 7,000 square meter facility. Only when all of them have been completed successfully is the engine transported to the Airbus factory in Toulouse. Toulouse in southern France. This is the aircraft manufacturer's largest production location. It even has its own airport. The engines delivered by Rolls-Royce MTOC are now mounted onto the A350. A short time later, the new aircraft stands completed on the apron. She's been given the name Bonn. The technicians have just installed the improved sharklets. Their special shape causes less turbulence and so reduces air resistance. The air flows more evenly past the wingtips, which increases the plane's range and reduces its fuel consumption. Calculated in terms of consumption per passenger over 100 kilometers, the new A350 uses just under 2.5 liters, which at the same time enormously reduces its CO2 emissions. In Toulouse, in the pouring rain, the final checks for the new airliner are underway. Everything is inspected and documented meticulously. As the machine is being delivered to the airline today, its own technicians are examining the Bonn particularly closely.
I'm in charge of quality check for the A350 here at the final assembly line and for deliveries. And you've just seen me up on the fin where I checked sealants and paintwork to see if anything's flaked off here and there.
Minor problems are marked with green adhesive tape. At a price of €265 million, nothing is left to chance. To assess the paintwork better, it first has to be wiped dry. A slight scratch is visible on the back of the rudder. Nothing serious, it's marked and will be polished out later. Meanwhile, in the nose cone, the plane's radar system is being checked. It is located in the cone directly in front of the cockpit and is essential for information on weather conditions and airspace control. The inspection is completed and the test crew are very satisfied. The aircraft is now ready for takeoff. At the briefing, the planned test flight is now discussed down to the most minuscule detail.
I'd suggest, first of all, that we do a pull-up, plus 0.5 G.
Yeah, I got that.
This particular maneuver briefly creates weightlessness inside the craft. Then they plan to roll the plane over on its side. A lot depends on the weather, which currently doesn't look too good in Toulouse. Benna Opsmeier is the captain on the flight and has years of experience. Taking account of the weather conditions, the flight plan is modified slightly so that all the tests can be carried out.
This test flight is all about flying to the aircraft's limits, checking the so-called protections, the safety systems.
An aviation engineer is also on board.
My role on board is the flight test engineer and the test conductor, and the one guiding the sequence.
An important task for the test flight ahead. The pilots are ready and start preparing the A350 for takeoff. This test flight is also the acceptance flight. Only if everything goes smoothly and no major malfunctions or problems occur will Lufthansa take the aircraft. The cockpit design has changed slightly and is now a two-person glass cockpit. A new feature is the mushroom-shaped mouse control handrests, which are also used in the A380. The display is made up of 6 38-centimeter LCD monitors. The content can be selected freely by the pilot. The aircraft slowly moves off. Everything looks good, and the pilot gives the order for takeoff. While the landing gear is still being retracted, the first readings come through. engine performance, speed, and cabin pressure are all within the normal parameters. The new Rolls-Royce engines and optimized aerodynamics reduce the aircraft's noise footprint by 30%, putting it well below the legal limits. The first test is a tough one. The aircraft flies horizontally at maximum speed, around 900 kilometers an hour, and then goes into a climb. After only a few seconds, it reaches the apex of its trajectory. The engines are now throttled back so that the thrust only compensates for the air resistance. The nose of the plane now points towards the ground again. In this phase, a clear reduction in gravity can be experienced in the cabin, almost like in freefall. Towards the end, the pilot pulls out of the dive by raising the elevator and ramping up the engines again. Test successfully passed. Now it's on to the next challenge.
Left and right up to 67 degrees.
The aircraft is now going to be rolled to a bank angle of 67 degrees. This places extreme pressure on the wings and is therefore a good test of their stability. As soon as the 67 degrees have been reached, the pilot lets go of the joystick and the plane rolls back automatically to a 30% bank angle. Always a thrilling experience, even for the testers.
These are, of course, tests that passengers in normal service will never experience. But they give us the certainty that all protections are responding and working properly.
Protections. These are the safety systems that intervene automatically in emergencies. Precisely such a system is responding now and wants to initiate descent. It seems there's a flap at the rear of the aircraft that isn't closed properly. A sensor reports noises from the cargo hatch. If this is confirmed, the test flight must be aborted immediately. Suddenly, the cockpit is full of technicians. Data readings are taken and compared. Measurements show that in the rear baggage compartment, air pressure is fortunately stable.
There's a minor issue with the AFT cargo door making a bit of noise. That needs to be sorted out. Otherwise, completely satisfied.
The test flight can continue.
We've done quite well so far. We'll just do one more so-called block at an altitude of about 3 kilometers, and then we'll head back to Toulouse.
This final block simulates pressure loss in the cabin. A very important test, because if this happens, the safety of the passengers is at stake. In today's test, only one of the many oxygen masks is released. The others have already been tested and found to be working perfectly. In an emergency, the aircraft's automatic system takes over. All the tests have been completed successfully and the team returns to Toulouse. After a 2.5-hour flight, the aircraft touches down at the company airport. A total of more than 40 different tests and maneuvers have been carried out. The crew is satisfied, and the Bonn can be taken over by Lufthansa. However, there are still a few minor issues to be sorted out. After landing, everything is carefully checked and examined once again. To cool the machine down quickly, all hatches are opened and covers removed. Time for the test crew to evaluate the data and make a final assessment.
There's always a great feeling when you see the plane flying at its limits. Martin flew it really well again, along with Wolfgang Abtsmeyer. It's quite frightening when you're at an angle of 67 degrees and you can see France flying by down below. That's what makes for really excellent flying with this aircraft.
Competitors Boeing are also relying on high tech and have built their own new super airliner, the 787 Dreamliner, which also boasts a lower fuel consumption thanks to modern materials. These advances increase efficiency, simplify the operation of the aircraft, and provide noticeable improvements to the passenger's experience. One of these innovations are the 787's new larger windows.
Most people are going to say, I really like the windows. And they will, and that'll be true. But there's going to be a lot more going on besides the windows that you can't even see that we did on this airplane. And you're just going to feel better, and you're not going to know why.
At Boeing, too, all aircraft are thoroughly checked and examined before they are delivered.
The 787 has enhanced stall protection. So enhanced stall protection allows the pilot to be able to have the full lift capability of the airplane at their command. And that underlies the overall Boeing philosophy of having the pilot in full command of the capability of the airplane.
Munich Airport. The crew of the new A350 Bonn is getting ready for their flight to Hong Kong. First, the cockpit crew has to order the fuel for the first flight.
So you've not flown the new route to Hong Kong yet either. Neither have I, but I was involved in the calculation. So I think we can order the fuel. Would you agree with 71 tons? Right. I'll enter that then.
Not long until takeoff. In a final meeting, the latest flight and passenger data are checked. The flight attendants are divided into teams, and the special features of the new aircraft are discussed once more. It flies faster than other aircraft and only takes 10 hours 30 minutes from Munich to Hong Kong. Then the crew make their way to the brand new plane. The A350 with the name Bonn has only been just delivered to the airline by the manufacturers. It has completely new, wider fuselage, new high-speed wings, and newly developed engines. Fueling is already underway. Before takeoff, Captain Jasper carries out the so-called ground check, in which he personally inspects the exterior of the machine once more.
Obviously, I can't see inside the system, but there are certain places you can look at to make sure they're in order, indicating the general condition of the aircraft.
The A350 Bonn is ready for takeoff. The pilots take up their positions in the cockpit. For safety reasons, there are always 3 pilots on long-haul flights who alternate regularly. The final provisions are stowed away in the cabin.
It's all brand new on this aircraft. You notice that as soon as you come on board, everything smells new. We're very proud that it's the staff based in Munich who are the first to fly on this plane.
And now the first passengers also come on board. The flight attendants have to deal with a completely new system. Though it's all been practiced in advance, things are often different in reality. Some things are not where they should be, but in general, everyone is satisfied.
It's definitely very pleasant. There's more space. Of course, it's a change from the A340, because there are 2 galleys here now.
At least there are in the new business class. The caterer has meanwhile delivered the food, and the cockpit crew is ready for takeoff.
The passengers are on board, we're excited, the doors are closed, we're taxiing, and I'm really looking forward to our flight to Hong Kong.
With 325 passengers on board, the Bonn taxis to runway and sets off from Munich to Hong Kong. On her first regular flight, she will cover some 9,000 kilometers without a stopover. Speed has always fascinated people. Ever faster cars and high-speed trains seem to make distances shrink. In commercial aviation, too, things are happening. Boom Industries is building an aircraft to fly from Munich to Hong Kong in just 4 hours.
To accomplish our goal of affordable supersonic travel, we challenged our engineering team to create a design at least 30% more efficient than Concorde.
Concorde was the world's first supersonic passenger airliner. It went into service in 1976, covering the Paris to New York route in less than 3 hours. After an Air France Concorde crashed in July 2000, the service was discontinued. For the first time since the Concorde, supersonic passenger flights could soon be in the skies again. The U.S. company Boom believes new materials are the key to achieving this.
Carbon fiber composites allow us to realize the aerodynamic design with a strong, lightweight structure. To create a carbon fiber part, we first start with a high-precision mold, either CNC machined or 3D printed. We then apply layer after layer of carbon fabric and resin to the mold. Finally, each part is cured in an oven or autoclave under vacuum at temperatures of up to 450 degrees Fahrenheit. Cruising at 1,451 miles per hour, the nose and leading edges of the aircraft can reach temperatures of up to 307 degrees Fahrenheit. These carbon parts outperform aluminum at the high temperatures of supersonic flight.
The propulsion system is composed of a variable geometry intake system and an efficient turbofan jet engine. Our engine is based on the same technology that powers modern subsonic aircraft, but with a customized fan and a variable geometry exhaust. Lastly, we use 3 engines for added reliability and safety. 2 engines are under the wing, and a third is in the tail.
Before actual construction of the new super airliner can begin, a lot of testing has to be carried out on the wind channel. A small model is built and covered with different materials. This is done to determine the behavior of different materials under strong wind resistance. If it is torn off or deformed, a better material has to be developed. Testing, however, is going very well. With a flying time of only 3 hours from London to New York, the engineers decided against seats with recliner function, preferring instead modern communications technology, ideal for business travelers. On its maiden flight to Hong Kong, the A350 isn't quite as fast, flying through the night at 950 kilometers per hour.
We're here in the larger central galley. The A350 has a few new improvements which other airliners don't have. There's a refrigerator where passengers can help themselves. We have a few environmental innovations for disposing of leftover food and drinks. And we also have a self-service area to make sure our guests are always provided for.
The air on board is also much better, a luxury that all classes benefit from.
This makes the cabin pressure feel lower, and as this is a long-haul aircraft, it contributes to making the journey in the A350 feel more relaxing.
There have been a few changes to the seats, too. They are wider and more comfortable throughout the entire aircraft. Even in the economy class, new standards of seating comfort now apply. The high-quality mounts and brackets here lead to significantly less vibration in the seats themselves.
We're in economy class today. This would have been a business class only a few years ago. If you look at the seat, we have 18.5-inch wide seats, better than any other aircraft flying in the skies today.
17-inch seats have been standard in many aircraft up to now. That's a little more than 43 centimeters.
The 17-inch seat is the seat that prevents you from movement. It prevents you from getting comfortable during that flight. Our industry is changing, and the needs of passengers are changing as well.
A study has shown that the sleep phase for people in 18-inch seats is much longer and more intensive than in 17-inch seats.
As the research has shown, 1 inch makes all the difference.
Onboard comfort has also improved for the A350 crew. They now have a proper sleeping cabin for up to 6 people.
And this is the so-called purser bed for me and my purser colleagues. That's because it's closest to our interphone. And the purser's the one in charge of communication, who has to make the phone calls. And this way you can make your own little comfort zone.
Another super airliner is the Boeing 777. Like the A350, it's used by all the leading airlines. The cabin equipment is modular and can be converted as required. In the 777, wider seats and improved cabin air are important features. Many countries have meanwhile placed orders for a special version of the Boeing 777. Among them, Germany's largest airline too. As a freighter, the 777 can really show off its capabilities. In this class, hardly any other plane can touch it.
It's one of the most efficient aircraft in the freight sector, the non-plus ultra in terms of what money can currently buy on the market.
The 777 has a revolutionary new loading system, with which freight containers are loaded on the aircraft by a lifting platform in a specified order. Each container weighs as much as a small car. The heavy containers are first transported to the upper deck of the hold by a sophisticated elevator system and then distributed evenly across its entire area. The procedure continues on the middle deck. Only at the end of the operation is the lower deck filled. Behind the cockpit, there's a small kitchen through which the crew members can access the hold. Captain Frank Lumnitzer checks the cargo. There's not a lot of space left for him to get through.
Anyone used to a passenger cabin will find this a little unusual. We've loaded 98,700 kilos of freight. I don't know yet the specifics of the cargo. I'll get that afterwards from the handling agent. Ultimately, it's freight that's either valuable or that has to be delivered punctually from A to B.
In here, 2 Greyhounds are waiting for takeoff. The freight documents have now arrived and are all in order. So now to the external inspection of the 777. A routine exercise for Captain Lumnitzer, who is flying the aircraft to Chicago today.
Our technicians have prepared the aircraft, and it's now down to me as captain to get my own impression of the condition of the aircraft. Boeing 777s are equipped with the most powerful engines available in commercial aviation. They have a diameter of well over 3.5 meters and generate thrust of over 110,000 pounds.
What makes this Pratt & Whitney engine so outstanding is a special kind of air compression. Air is continuously compressed over a number of individual compressors, also known as fans, before it's mixed with kerosene. This mixture is ignited and drives the turbine. The turbine exhaust then provides additional thrust and turns this engine into a super engine. The Boeing 777 is now ready for departure.
So, it's time to go. We're off to Chicago, and we want to be punctual.
With a range of 11,000 kilometers, the 777 operates a network of almost 300 destinations from Frankfurt. Back on board the A350, Hong Kong is already drawing much closer. The Bon is just crossing the foothills of the Himalayas.
Below us, the 6-kilometer-high Tibetan Plateau, but the aircraft is running well, the systems are working excellently, and the fuel calculation we made in Munich seems to be working out. We'll have enough reserves when we get to Hong Kong.
All the other parameters are also keeping the pilots in a good mood.
This is the most modern commercial aircraft currently on the market, and you can really see that too. When I compare it with all the other models I've flown so far, like the A340 or the A330, this is a completely new generation, with a cockpit very similar to the A380.
That's due, amongst other things, to the mouse control and freely assignable monitors. The automatic height control for both aircraft is in the middle of the control unit. There's also a kind of tablet on each side of the cockpit on which the pilots can look at map material. The aircraft now begins its descent. The map of Hong Kong Airport has been loaded to prepare for this.
As expected, the aircraft held up very well and flew reliably. We're now on our approach and will soon have completed 10.5 hours of flying. And of course, I'm looking forward to the landing and our stay in Hong Kong.
But unfortunately, the A350 has to take a slight diversion. The airspace over Hong Kong is so crowded that the aircraft has to circle amidst the clouds. Time for the pilot to switch to manual control. In the clouds, visibility is down to 0 and the pilot has to rely blindly on his instruments. Suddenly, the cloud cover breaks.
That's central there, the center of Hong Kong. And on the other side, that's Kowloon.
Finally, the tower gives landing clearance. The airport lies on one of Hong Kong's many islands. In the cockpit, complete concentration.
7, 60, 50, 40, 30, 20, retard, retard, retard.
With retard, the aircraft tells the pilots to reduce speed and activate the brakes. Everything went well. Hong Kong International Airport lies on an island and is almost completely surrounded by water. That's why the approach poses no problems.
The A350 was my first flight to Hong Kong. It worked out quite well. We had to fly a bit of a zigzag. We don't know why exactly, but never mind. We're here now. A bit late because we had to wait in Munich, but it all worked well.
While the crew looks forward to a well-deserved rest, the pulsating life of this great metropolis awaits the passengers. Over 7 million people live here. The densely populated city center has an important port, and the skyscrapers in the financial center shape the skyline of this great Asian city. A huge festival celebrating the national holiday takes place here every year on October 1st. Right near the airport is the base of LSG Sky Chefs. The catering business is a Lufthansa subsidiary and the second largest supplier of onboard catering services with a worldwide market share of 20%. In 2017, the 35,000 employees produced around 696 million meals, achieving a turnover of 3.2 billion euro. The LSG Hong Kong warehouse has absolutely everything. Here, the catering for the return flight of the A350 Bonn is being prepared. The trolleys are still empty and have to be filled up with glasses, drinks, and snacks.
The packing list from Lufthansa, and then we will follow the part number here indicated, and we will pack according to all the items here and also the quantity.
Every day, cutlery for over 10,000 passengers has to be cleaned and packaged, all by hand. Cooking for extreme conditions. At an altitude of 10,000 meters, the sense of taste is altered by low pressure and low humidity. The effect of spices is weaker. The chefs know exactly which strong flavored dishes bring the taste buds back to life. Rolls and side dishes are freshly made and then individually packaged. More than 10,000 every day. The sauces are also a little thicker, so they won't be thrown off the plate during turbulence.
Challenging every day more than be executive chef than a hotel, because you need to satisfy so many different customers every single day.
The chef is always there, keeping a watchful eye on the preparation of his creations.
I can cook everything alone for airline, all right? So I have a team. But I need to make sure to bring what I want and my vision of the food I have for the customer. They can produce exactly the same.
All the food for the return flight of the Bonn to Frankfurt is prepared by 3 chefs at the same time. And this is just for the business class passengers.
The only way to prove yourself and to make your staff trust you is to cook, to show them your value, and to show them, like, when you say something, you know what you talk about it.
It's very important that no dish is higher than 4.5 centimeters. Otherwise, it will touch the next tray in the tightly packed trolley. So here, even star chefs like Michel Boussemont have to observe the limits dictated by dimensions. The trolleys are packed and can now be loaded. Through long corridors, they are taken to the refrigeration carrier. In the control center, the orders and alteration requests are processed. With so many flights and meals, it's extremely important for the chefs to maintain an overview.
Let's say for Lufthansa, we have 66 business class. We produce for 66 business class. Maybe there are 40. We have 26 extra, but this is a top-up.
Safely packed onto the trolley, the Bonn's onboard refreshments begin their journey to the airport. There's still time. The Lufthansa A350 doesn't leave Hong Kong for another 90 minutes. So loading can be carried out as scheduled. One trolley after another is loaded onto the refrigerated truck. Now they drive to the airport. The LSG refrigerator trucks dock onto the A350 and the food is unloaded. Meanwhile, the crew is back on board the Bonn and is preparing for the return flight. In only a few minutes, everything is finished and the aircraft sets off for the runway. After her successful maiden flight, the A350 will from now on fly back and forth from Munich to Hong Kong on a regular basis. Demand for modern airliners is growing. China, in particular, is ordering various aircraft models in increasing numbers. In fact, the People's Republic has only recently taken delivery of its 50th A330. This development has prompted the manufacturers to further optimize production.
First of all, we continue the ramp-up of the A350 to be ready to deliver on our commitments in 2019, which is 60 aircraft a month.
Another very important subject is the future of mobility. Aircraft manufacturers want to test new concepts for improving short-distance travel.
We now start to take care of the full mobility experience as long as flying is involved. So we look at things from door to door, including ground transport, about security, operations at the airports, doing the flight, but making it an experience for the passenger.
One ambitious project is the Vahana air taxi, which developers see as a way of rising above urban traffic chaos in future. Using an app, passengers call the air taxi and have it fly them to their destinations.
It's being developed by our colleagues in Silicon Valley, Vahana, which is a tilt-wing, single-person urban air mobility vehicle.
Vahana is 5.7 meters long and 6.2 meters wide. Its takeoff weight is only 745 kilograms, and most importantly, it flies autonomously, without a pilot. Obstacles such as birds or other drones are evaded automatically. The pop-up concept is pursuing a different principle. It's actually quite simple. On the ground, the pop-up drives like a normal vehicle, but for longer journeys, a huge quadrocopter comes along and docks onto the vehicle. When the pop-up reaches its destination, the journey can be continued by road. And the best thing is that the passengers need neither a pilot's nor a driver's license. The electric ground aerial vehicle travels fully automatically.
A commitment of Airbus to look at the future, work on the future, and take the challenge of the tough commitments the aviation industry has taken for sustainable growth.
Frankfurt Airport. This is another super airliner, the A380. Today's flight to Texas is something special because on board the workshop for the future Flying Lab is being held.
Flying Lab is our open innovation platform for bringing digitalization closer to people. It's an opportunity for our guests to experience live on board what the future of aviation will be like and how flying will change in the future in terms of concepts and approach.
Today will be about presenting new uniforms and partly about new seats too.
On flight LH440, that will be going on in every class, whether economy or business class. The gigantic jet is ideal for this project, as it has plenty of space for a mobile studio. After takeoff, the mobile studio is set up in record time, and after a few minutes, the workshop starts. The presenters introduce the latest visions for the future, and the passengers can watch the presentations live on their smartphones and tablets. The almost 11 hours of flying time can also be used for extensive tests of future technical products, an opportunity for passengers to take an exclusive look at some new ideas. A flight into the future, so to speak. This newly developed seat, the so-called Smart Chair, is something really special. The aircraft seat of the future can be heated, ergonomically adjusted, and contains an integrated cushion with individual settings. On display in the so-called cocoon, the flight attendants can read any special wishes a passenger may have. When lowered, the cocoon greatly enhances passenger privacy. At the same time, its display makes the onboard entertainment system a very different experience. During takeoff and landing, the seat automatically reports whether all passengers have their seatbelts on or not. The seat's colored light signals also make boarding and leaving the aircraft easier.
Basically, it's about technology, it's about research and technology, it's about investing in innovation, and it's about people. It's about getting and retaining the best talents, being able to attract the talents and the technologies of the future to help us build the aircraft of tomorrow.
A leap forward to the year 2050. What will the super airliners of the future be like? Transparent walls, bioactive seats, interactive onboard entertainment, and plenty of room for passengers could all become reality very soon. This concept plane has already been developed and presented to the public.
People really saw how the future could look like and also saw all the opportunities of the future. Virtual reality, playing golf, transparent windows. Interesting also question about social media. Will Facebook replace actually meeting? And the answer is no. We need still to meet and make the journey as short as possible, door to door, including airports, immigration, checking, not just the flight, but the complete experience.
There still seems to be a long way to go from the A350 to the concept plane, and the airlines are helping to speed up this development.
It's a continuous process based on our experience in daily scheduled operations and close contact with the manufacturers. We help to develop new solutions for future aircraft, which can then later be found in our own fleet.
The right mix of new technologies will determine the future of air travel and generate even better super airliners for the next millennium. Aviation can look forward to an exciting future.